Hey everyone, and welcome to This Explainer. If you're a focused learner looking to really understand the mechanics behind environmental compliance and industrial air pollution control, well, you're in exactly the right place. Today, we're looking at a pretty fascinating shift in industrial standards. Specifically, we're diving into the performance evaluation of dry dust collectors. And we'll see how evaluating these massive systems went from being a notoriously frustrating process into something dramatically simpler and way more effective.
All right, let's dive right into our roadmap for today. We'll be covering evaluating dry dust collectors, the old way with dual measurements, the 2017 revision known as Method 2, how Method 2 actually works, and finally, the practical benefits for facilities.
Section 1. Evaluating dry dust collectors and the absolute importance of grade efficiency. Let's get into it.
So for you environmental health and safety pros out there, you already know this evaluation isn't just about ticking a regulatory box. It's really all about grade efficiency. That is, the efficiency of a dust collector per a specific particle size interval. It doesn't just tell us how much dust a collector catches overall, but how well it captures dust at very specific, and sometimes completely microscopic, sizes.
To measure this, you really have to look at the system as a whole. In a typical confined flow system, you've got your flow moving from a boiler, through the dust collector, and then out to the stack. And the underlying assumption for evaluating performance here is based on a really basic law of physics. In a system with no leaks, whatever dust goes in simply must come out, either captured by the collector itself or emitted right through the stack.
Moving on to Section 2, the old way, specifically the 2003 standard. Let's build a little empathy here for how frustrating these old rules used to be. Under the 2003 standard, facilities had to perform simultaneous inlet and outlet measurements at isokinetic conditions. That meant the sample had to be pulled into the probe at the exact same velocity as the gas flowing through the duct. You'd have one team fully rigged up near the boiler taking high dust samples, and an entirely separate second team stationed way up on the stack taking outlet samples. The heavy manpower, the complex scaffolding, trying to coordinate the safety protocols of two teams at once, it was literally a logistical nightmare.
And there was an unhappy side of this 2003 alternative method. Aside from needing two full sampling teams and those complex access platforms, your flow measurements had to be incredibly accurate. But here's the kicker. The underlying standard used for measuring mass concentration, MS 1596, actually has an inherent inaccuracy of up to 10%. So because of this built-in flaw, you actually needed a minimum of 3 conclusive tests just to get reliable baseline data.
And on top of all that, you had to deal with extreme variations in the sample itself. Think about it. You're trying to measure the massive high dust load at the inlet at the exact same time as the vastly lower dust load at the outlet. Taking an accurate, tiny sample from a high-velocity, high-dust stream without skewing the particle size distribution was notoriously tricky. It was honestly kind of like trying to catch one specific snowflake in the middle of a blizzard.
Which brings us to Section 3, the 2017 revision, Method 2. Finally, a streamlined approach.
Fortunately, standards evolve, bringing a huge wave of professional relief to the industry. I want you to let this sink in for a second. No need for inlet measurement. That single sentence, drawn straight from the updated methodology, completely transformed the workflow for plant managers and environmental compliance techs everywhere.
When you actually compare them side by side, the sheer contrast in resource allocation is just stunning. Over on the left side, you've got the old 2003 way. Dual measurements, 2 teams, simultaneous testing, high complexity. Now look at the right side, the 2017 Method 2. Collected dust measurement. You literally only need one team. You only test at the outlet, and instead of trying to sample dust flying through the inlet duct, you just rely on manual dust collection.
Let's jump to Section 4, how Method I works and how it simplifies performance evaluation.
So how does Method 2 actually translate into an actionable procedure on the factory floor? Well, it boils down to 3 super simple logical steps. First, you set up your single isokinetic sampling team entirely at the outlet stack. Second, instead of measuring the inlet gas, you manually collect the separated dust directly from the collector's hopper. And third, you take that massive dust sample along with your outlet readings and you analyze them to calculate your grade efficiency. It completely bypasses that dreaded inlet measurement.
Notice how cleanly the new data flow is separated here. The complex gas analysis, like gas temperature, moisture content, and volume flow, are all handled solely at the outlet now. Meanwhile, the dust load and particle size distribution are derived entirely from what is manually collected and what escapes from the outlet. It's just a remarkably straightforward mathematical model.
Now, an absolutely crucial component of this new manual collection is the collection bag itself. According to the standard, this bag has to have a minimum storage volume of 1 cubic meter and be able to withstand high temperatures. Think about what this means in practice. Instead of relying on a tiny, error-prone probe sample from a high-speed inlet duct, facilities are gathering a massive, physical sample straight from the source. And as we know, large samples mean way fewer statistical anomalies.
But don't worry, even with this simplified manual collection, the math remains completely rigorous. By normalizing the mass per particle size interval, we can perfectly map out the relative outlet particle size distribution. So by comparing that massive manual sample against the outlet data, the 2017 formulas give us a highly accurate final grade efficiency. It shows us exactly how well the collector captures both large and fine particulate matter.
Finally, Section 5, Practical Benefits for Facilities, and why this matters to you.
So, why does this regulatory evolution actually matter to the daily lives of environmental compliance technicians and facility managers? Well, because Method E is a genuinely empowering tool. Right out of the gate, it halves the required sampling manpower. The manual collection method is vastly easier, and those massive samples completely eliminate the frustrating small sample statistical errors we saw in the old days. And importantly, this inclusive standard fully applies to other dry filters too, like electrostatic precipitators, or ESPs, and fabric filters.
Method 2 essentially took a complex, expensive, and stressful compliance requirement and transformed it into a highly practical tool that end users can actually use to understand their equipment's separation characteristics. So I'll leave you with this final thought to consider today. Is your facility ready to simplify its performance evaluations and unlock the true grade efficiency of your dust collectors? Thank you so much for joining me on this explainer, and as always, keep learning.